Hey everyone, Maya here, and this is Mathelingual. Alright, so today I'm going to wrap up the talk on inequalities, well, plain inequalities. Next week I want to start touching into touching based on absolute value inequalities. But for today, it's just going to be this one video with two little examples demonstrating the difference between an and inequality versus, well, I guess that'd be weird, and an or inequality. So we're going to see today the difference between these two kinds. So the main thing with an and inequality, as the name suggests, you're going to find all values of the variable that make both inequalities true, right? So like if you have A and B, you want to find the values of the variable, the solutions that make A and B true or correct. But with an or inequality, you're just looking for at least one of those inequalities to be satisfied. So you're going to find, for an or inequality, you're going to find all values of the variable that make at least one inequality true. So really it's like if I have A or B, find the values that make either A or B true. Okay, so let's jump into an example. So let's say I've got, for an and inequality, I have 7 is less than 2x plus 1 and 3x is less than or equal to 18. All right, so what happens here, I'm just going to simplify as normal. So for this inequality on the left, 7 is less than 2x plus 1. I'm going to subtract 1 from both sides to further isolate the variable x. So that means 6 is less than 2x. And then I'm going to divide both sides by 2 to cancel out that 2. So 3 is less than x, or x is greater. 3 is less than x, or 3 is, or x. Oh, let me start that. 3 is less than x, or x is greater than 3. Okay? So now for this one over here, it's just a one-step equation, a one-step inequality process, a one-step solving. So 3x divided by 3, that cancels it out. 18 divided by 3, that's 6. So x is less than or equal to 6. So what happens is we can graph this. And I'm just going to draw a little number line, nothing fancy. 1, 2, 3, 4, 5, 6, 7. Okay, so let's say this is -1, 0, 1, 2, 3, 4, 5, 6, 7. So over here, I'm going to have x is less than or equal to 6. So I'm going to have the closed circle because 6 is included in that solution. And it's going to be going like this way, right? Because x is either 6 or less than 6. And then you're going to have x is greater than 3. So open circle because 3 is not part of that solution. And it's going to be going this way, okay? So you look at where those two meet, which is right here. So what we can do is actually we can combine these two inequality solutions or collapse the and inequality. So we can say that 3 is less than x, which is greater than or equal to 6. So what we would read this as technically is x is greater than 3 and less than or equal to 6. So this is your and inequality solution, right? So you're finding those values that satisfy both inequalities, which is why you can therefore collapse that solution. Now let's take a look at another example with an or inequality. So let's say I've got 7 plus k is greater than or equal to 6, or, keep in mind the or 8 plus k is less than 3. Now I'm just going to simplify as usual. So over here, I'm going to subtract 7 from both sides to isolate k. And what that means, well, actually that doesn't cancel, but we're just going to simplify. So 6 minus 7 is -1. So k is greater than or equal to -1. negative 1. Okay, now for the inequality over here, we're just going to subtract 8 from both sides. So, cancel over there, but not over there, we're just subtracting. So k is less than negative 5. So you can see why this is an or inequality, because it's got to be greater than negative 1, or it can be equal to negative 1, but then it's got to be less than negative 5. That is why this is or. You can't have, there is no number that is both bigger than negative 1, but less than negative 5. That's why it's an or inequality. So as with the first example, the and inequality, for this or inequality, we can graph the solution. And again, by graph right now, I don't mean a Cartesian plane or the coordinate grid. I just mean a number line. Took me a moment at first to realize that's what they meant, because I'm used to graph meaning your typical Cartesian plane, but not yet. Okay, so for this one, the k is greater than or equal to negative 1. What that means is this is going to be a closed circle because negative 1 is part of that solution, that set of solutions, and it's going to be going this way. And then over here, k is less than negative 5. It's going to be an open circle because negative 5 is not part of that solution, that set of solutions, and it's going to be going this way. So you see, unlike over here, they do not intersect. They go in different directions, right? So it's either, right? So it's either. It is either negative, it's either k is less than negative 5 or k is greater than negative 1, right? So if I pick a solution over here like negative 7, that is going to satisfy this equation over here, right? Because negative 7 is less than negative 5. Or if I go over here and I pick k equals 0, that'll satisfy this equation because 0 is more than negative 1, right? So I am making one inequality true, but not both. Both inequalities true means it would have to be an and inequality, but an or is just at least one. So I'm just going to write that in parentheses here. So both equal true. So, right, this is what you got to look for with an and inequality. Does your set of solutions make both inequalities true? Whereas with an or inequality, you're looking for is one true, right? Because you really can't satisfy both. And this is an example of why, because it is an or inequality versus the and. So that sums it up for this week on the and or inequalities. So till next time, I'm Maya, and this is Mathlingual out.